All right, so 6.3 in your textbook. If you want to get that out, let's see. In your Pearson, Math Makes Sense, 6.3 is going to be around page 288. Page 288. So we're taking a look at linear inequalities now. So we've spent a lot of time on equations, linear equations, and we have solved linear equations. We've in chapter 4 we sketched them out, right? We drew straight lines. We took a look at a table of values and we're able to plot some points. And so we know about linear equations. Now we're going to learn about something a little bit different called linear inequalities. So please notice, I gotta find my pen here. So please notice that inside the word inequalities is the word equalities, okay? So what does it usually mean when you have in or anti or un or something in front of a word? What does that mean? Maybe you can grab that door for us. Shut that door for us. Thanks, Scott. So what does that mean when we have a word like in front of a word?
It's the opposite.
Yeah, it's like the opposite, right? So inequality, it would be like justice versus injustice. What are inequalities? Inequalities. We use inequalities to model a situation that can be described by a blank of numbers instead of a single number. What do you think? What do you think goes there? So think about an equality is a single number as an answer that fits in the equation. So if it's an inequality, we're not talking about a single answer anymore. We're talking about a pair. That's a good guess, but it better maybe described as a range of numbers. Okay, so there could be more than two. A pair is usually just two, right? So there could be more than two. There could be a range of numbers. We often also, when we're talking about inequalities, we use symbols like greater than or equal to another quantity. So greater than would be an example of an inequality. And there are some symbols. So greater or equal to would look like this. You guys seen these symbols before? Okay. Now, when I was young, when I was in school, my teacher used to try and help me understand which was the greater than and less than sign, you know, which way does it kind of go. And if we had two numbers, for example, like 5 and 3, well, 5 is it greater than or less than 3? 5 is greater than 3. So the sign that would go there would be this one. And this is the way I learned it, and this is the way I still think of it sometimes. She said, well, this is like the mouth of a crocodile. And this crocodile wants to eat the larger amount of food, you know? So here's this big, mean old crocodile here. So whichever way the mouth is opening up to, that's the larger one. So if we read it as greater than, that means the first thing on the left is bigger than the thing on the right. So that's why we have the mouth opening up to the left there. Now, if it's or equal, and I'll give you some examples here in a minute, but if it's or equal, we're going to show that equality is acceptable as well by putting one single kind of line of the equal sign. We're going to put one line underneath. Okay? And again, this should be a little bit of review. I think you've seen this before, but okay. When one quantity is greater than the other quantity, so not or equal to, we do this symbol right here. Just that one with no line underneath. Okay? So greater than has no line underneath. When one quantity is less than or equal to the other quantity, less than or equal to, that is this opposite. It opens the opposite way, and then we do have a equality symbol underneath there as well. If it's just less than, it's like this. Okay. Have you seen those before? No? Never seen those before? Yeah, some of you have? Okay. All right. You should have seen those before. Yeah, you should have seen these ones before. All right. Which inequality describes the amount of time, t, for which a car could be legally parked? So you see this kind of sign on the streets downtown. right here. So what does this mean? This means that a P with a green circle around it means you're allowed to park. Okay, go ahead and park. Green means go. 30 minutes, 9 a.m. to 6 p.m., Monday to Friday. So if you think about that in terms of an inequality, which inequality describes the amount of time this car can be legally parked? Any ideas here? The first option, second, third, or fourth? Let's call it that way. Any ideas?
Less or equal to?
Okay, less or equal to. So which one is that? The first, second, third, or fourth one? Yeah, it's the third one. So t is less than or equal to 30. So you can park anywhere up to a maximum of 30 minutes. So can you park exactly 30 minutes? Yeah. Yes, you can. So that's equal to. Can you park 5 minutes? Yeah, or 6, right? 10, 12, 17, 25. You can park any of those. So t is, I'll make that a little bit bigger. T is less than or equal to 30. The time that you can spend legally parked is less than or equal to 30. Okay, let's get some more practice. And you deal with inequalities all the time. Maybe you don't even realize it. But here's another sign. Now this is more of an American sign. This would be miles per hour, but the speed limit is 55. So what do you think, first of all, what's a good variable that we could use in this situation? What's a good letter that we could use? S? Okay, I like that, S. Now why would you choose S? Speed, exactly. It's a good idea to choose a letter that represents the quantity well, and so if it starts with the same letter, that's perfect. So S. So speed limit is 55. So what kind of symbol should I put here? I'm assuming 55 is going to be part of this inequality, right? You'd be right in saying that. So what do you think would go here? What's allowable? Less than? No? Not less than? Okay. But is greater than? Do you think greater than?
Wouldn't it be less than? Because that's a limit.
Okay, it's a speed limit, so that's not a lower limit, right? It's not like you can't go any less than 55, you have to go more than 55, right? Yeah. It doesn't mean that. It means you can go less than 55, so you were right to say less than. Now the question is, can you go exactly 55 and still be okay?
Yeah.
Right. So should we put a little equal sign underneath here?
Yeah.
Yeah, I agree. Very good. Very good. So speed limit 55 means that your speed can be any number less than or equal to 55. Question?
Wouldn't you still get in trouble the same way you would go by going over the speed limit if you went too low?
Yeah, we're not, no. This sign means that you can't go over 55, but you can go less than 55. So we're not going to talk about if you're a dangerous driver going 2. We're not going to talk about that. No, no. Ignoring that possibility, yes. If you're going 2 miles an hour on a highway, then yes, you could be pulled over for something, yes.
Ridiculously slow.
But that would be another inequality situation, which you will get to later. But okay, so good point though. Height restriction. Okay, you must be at least 102 centimeters to go on this ride. You must be at least 102. Okay, so I read the word least, so that sounds like less to me. Is that would you agree with that? Oh, I see some heads shaking.
Or no more.
I see some head shaking. So if this is like at a carnival or something, you know, you have to be large enough to fit in the straps or whatever. Maybe it goes upside down or something. So they would say something like this. So if you must be at least 102 centimeters, so let's say that h maybe is a good variable for height, okay? So it's height restriction, I'll use h. So this is seeming to indicate that anyone that is larger or taller than 102 centimeters would be able to go on this ride. Would you agree with that? Okay. So what symbol should I put here, do you think? Greater than, and is it okay if you're exactly 102? Yes, at least means 102 or above. So we'll do this one. And then the number would be 102, okay? So on a number line, right? On a number line, if we were to draw a number line, you could see that, hey, 102, let's say 102 is over here. So anything that's greater than 102 is okay. So this is okay, 102, and anything greater than. So it's all of the numbers conceivable greater than 102 centimeters. Okay? All right, next one. Let's go a little bit quicker here now. So this is milk stored at temperature below 4 degrees Celsius. So I think that what we're talking about is temperature, so I'm going to put T there. Is that okay?
Yeah.
T for temperature. Below 4 degrees Celsius, what would you put for an inequality there? So it's anything that would be what? Less than or greater than, do you think? Less than. What about if it's equal? Could it be equal to? It says below only, right? It doesn't say 4 degrees or below. It just says below. So I would say that this is great. Now, should we put units on these? Probably. This one doesn't give us units. This one gives us centimeters, so that might be a good idea. We do have to remember that these values do carry units, so units would be a good idea. For the most part in math, if it's not a word problem, you don't have to use units if it's just numbers. Okay, finally this one. Canadian home video rating, 14A. Do you guys know what this means? What those numbers mean? 14A, PG-13, 18A. Sorry?
Is that like the age restricted?
Yes. I think those numbers would refer to the age. So it's not recommended for anybody under 14. So are you guys anybody under 14 here? You guys are all 14 or over, right? Wow. Oh, somebody's under 14? Okay, close. Well, it doesn't matter if you are. I'm just saying most of you would be able to watch whatever this is, so technically. So, okay, let's do this. What's the variable we should use here, do you think? What's a good one? A for age. Thank you. A for age. So A, 14, so is it 14 and under or 14 and over? 14 and over. Right. So that's going to be, your age must be greater than or equal to 14. So the age has to be bigger than or equal to 14. The alligator or crocodile, whatever it is opening up towards the A because it is bigger than 14. Okay. Any questions on that? Because if you understand this, that's what you need. You need to understand sort of this these situations. That's great. Okay. Example 3. Define a variable and write an inequality to describe each situation. Okay. A. Contestant entrance must be at least 18 years old. At least 18 years old. So let's say A is age. Okay. A is age. And we're going to say A is what compared to 18. So the ages that are allowable are greater than, less than, greater than or equal to, less than or equal to. What should we put there? Sorry, what did you say? Greater than, yeah. So let's put a greater than sign. Is 18 years old okay?
Yes.
At least 18. So if you're 18, you're good. Excellent. Okay. Okay, I'm going to do the next one, then you're going to do the next ones after that. So the temperature has been below -5, I think that's supposed to be a degrees, not 50. -5 degrees Celsius for the last week. So let's say T is temperature. T represents temperature. And T, the temperature has been below -5. So T has been less than -5 degrees Celsius. You guys agree with that?
Yeah.
Okay, you guys do C and D. Do C and D, and then I'll check in with you here in a minute and see how you did with that. Make sure you define your variable just like I did in A and B. All right, so you can look up to the board here if you haven't already yet. I put I as items, 10 items. If you did another variable, that's fine, as long as you clearly labeled what it was equal to. And then you have to have 10 items or less to use the express checkout. So I is less than or equal to 10. You guys agree with that? Everybody have that? Pretty good? Yeah. Okay. Scientists identified over 400 species of dinosaurs. So D is species of dinosaurs. It's over 400, so I'm going to go D is greater than 400. You guys okay with that? Yeah, good. Thumbs up. Right on. Okay, let's keep moving on. All right, a linear equation is true for only, now we're talking about an equation here, is true for only one variable, or one value, I should say, one value of the variable. So that is, there's one solutions. A linear inequality is maybe true for many values of the variable, which we already kind of talked about there. So there's many solutions. The solution of an inequality is any value of the variable that makes the inequality true. All right? And making an inequality true would basically be saying like 5 is greater than 3. That is true. Okay, so 5 could be, if you're putting in a number in for a variable, if the number makes the statement true, then that's a possible solution. There are usually too many numbers to list, so we can show them on a number line. And one of the ways of stating the solutions is by drawing a number line. So here's an example. So the example 4 says, is each number a solution to the inequality b is less than, or that's greater than? Which one is that? Which one is this symbol right here? Yeah, that's a greater than, right? Right? Opening to the larger one. So b is greater than or equal to -4. So we have a number line here. So let's compare the numbers that are given to the number line. So is -8 greater than -4? Because on the number line, we have -4 as part of this, and then everything to the right of it, because it's everything that's greater. So is -8 a solution here? No, it's not. Why? Because -8's over here. It's not in the red sort of solution area. -3.5. Well, -3.5 is right about here. Is that a solution? Yeah. It is. Now, this is very important because a lot of students get tripped up on this. So this is a true statement. Even though 3.5 looks smaller than 4, when it's in the negative area, a smaller number is actually greater. Okay? If you think about this as temperature, -3.5 degrees Celsius is warmer than -4. So it's to the right on a number line. Okay, does -4 count as part of this? Yep, that's part of the solution. It's on where the red is. So, so this is yes, this is yes. 4.5. Well, it's a positive 4.5. So positive 4.5 would be right here. So that looks good. That one's a yes too. And 0, well, 0's right here. It's a yes as well. Any questions? This is probably, I know this is probably super easy for you, so I'm glad if this is super easy for you and you're getting this, then that's actually great, okay? It's not a waste of time. We're just making sure that everybody is on the same page here. Now, the other method would be to substitute the letter or the number in for the letter. So for example, is -8 greater than or equal to -4? That was our first one. Well, is that true? No, it's not true. That is less than -4. So that's why no for -8. I won't do all of them, but certainly 4.5. Is that greater than or equal to -4? Yeah, that's much bigger than a -4 because it's positive. So this is a yes. And this is what I mean by the statement is true. If the statement is true, right here, like this is a true statement, then that number is a solution. Okay, any questions about that? The one solution versus many solutions, pretty important. Okay, graphing inequalities. Okay, for example, what would a greater than 3 look like on a number line? Paying attention? Hunter? Thank you. What would a greater than 3 look like on a number line? Well, you go to 3, because that's the number that's mentioned, and you draw a circle around it. Why? Because if you look closely, this is not including 3. It's just everything that's bigger than 3. So that's where you use an open line there. Sorry, an open circle. Or is it? I'll get it on the same. So 3 has a hollow circle there. And then you draw a arrow to the right. When you're drawing your arrow, you can draw your arrow just above the line too. You'll see sometimes, because sometimes it's hard to draw right on the line, so you could go like this. So an arrow just above the line is acceptable as well if you're doing it. So remember, on a number line, greater is to the right, less than is to the left. B is less than or equal to -5. Well, with that equal sign there, -5 is included, so that's a solid dot on -5. It just means that -5 is part of the solution. And then because we're doing less than, the arrow goes to the left on the number line. You can also do this, solid line on -5, and then an arrow above the line like that. So again, just to note what I said here, since in the first example 3 is not part of the solution, we draw an open circle. An open circle at 3. And -5 is part of the solution, so we draw a solid circle here. If you don't like open, you could write hollow. That's another good way to describe it. An open or a hollow circle, empty circle, and then solid. Any questions? All right, you guys are doing good. Let's keep going. All right, so here's your chance to get a little practice. I'll do the first one for you, and then you can do the rest. Graph each inequality in a number line and list 4 numbers that are solutions of the inequality. So I'll do the first one for you, and you'll do the rest just like this. So t is greater than 9. So obviously we spot the number that's in the inequality. Here's the number right here. Here's 9. And so do I have an equal sign here as well? And the answer is no, I don't. So that means that 9 is not part of the solution set. And the range of numbers that satisfy an inequality, as you will find out when you get into high school in the older grades, we call that a solution set. So it's a set of solutions. So I might say that. That's what I mean. So 9 is not part of the solution set. So we will write empty or hollow or open circle there. Now, which way do I draw my arrow? If all of the solutions are greater than 9, should I draw the arrow to the right or to the left? All right. So, well, let's do this part. Let's do this part first. Let's list some numbers that make this true. Is 8 greater than 9? No, 8 is not greater than 9, right? Because it's to the left here. So 10, is that greater than 9? Yeah, so 10 is part of the solution, so we're going to draw that arrow to the right. Okay, t is greater than 9. All right, now this gets a bit tricky when the variable is on the right side. So let me just pause and explain this one to you. A good idea is to read the inequality from the variable, okay? So in this case, we did t greater than 9. In this case, I would encourage you to read it from the variable. Start with the variable. The solutions, that is x, are less than. If you read it this way, this becomes a less than sign. See, x is less than -2. Now, I like doing it that way. You can think of this too. -2 is greater than all of the possible solutions. -2 is greater than or equal to all the possible solutions. So that's going to turn out to be this. We're going to go to -2, and because there's a little equal sign there as well, we're going to fill that in, solid. Okay? These should be negative here. They're not giving you, oh, wait a minute. Oh yeah, this negative is, yeah, these are not. So apparently -2 is not on here. So here's going to be 0, here's -1, just add this. Here's -2. Okay, so there's -2. We're going to make this a solid dot because it's or equal to. Good. So if all the possible solutions of x are less than or equal to -2, I'm going to put my arrow to the left because they're all less than. If you read it the other way, that -2 is greater than or equal to all of the values of x, then still you have to show on the number line that everything to the left of -2 are the answers. So whichever way you look at that, doesn't really matter. Like I say, I always read from the variable. Okay? Now, what we haven't done here is list all 4 numbers, so let's do that. For B, 4 numbers that would be included would be -3, -4, -5, and -6. Those are all this way on the number line, right? And over here, we could list 10, 11, 12, and 13. Or any other numbers greater than 9. Okay. So you guys take a minute and do C and D. Do C and D. And let's just see. I think these numbers... let's make this one a positive, guys, here, because it's not on the number line. So let's make this one a positive. Yeah, make that one a positive, so you don't have to make a new number line. So D, make that a positive on your notes. All right. You can look up on the board when you're done. Your numbers might be a little bit different than mine. I just chose 4 numbers at random. But let's take a look here. So at 0.5, you want to put a solid dot because it's or equal to. And 0.5 is less than all of the answers that should be identified. So this should be the one that's furthest to the left. Or, like I say, you could read it from A. A is greater than or equal to 0.5. So the arrow should go to the right. How many of you got that correct? Put up your hand. Got that correct? Yeah, excellent. Good to see. Okay, D. P is less than 25 over 3. So 25 over 3, you can convert that to a decimal if you want. That's just a little bit more than 8, so 8.3. So it's going to be over around here on the number line. And the possible solutions for P are all the values that are less than. So we'll put the arrow going to the left. And then you list your possible solutions. So I listed this one, this one, this one, and this one. I listed this one, this one, this one, and this one. Okay, any questions? All right, I'm going to pick up the speed a little bit because you look bored, so I think you guys are getting this. This is probably too easy for you, right? It's like baby stuff, is it? I don't know. Pretty easy? Pretty easy? Okay. All right, so write an inequality to describe each situation, then graph on a number line. A number that is greater than 5, so a number greater than 5. I'll just do n for a number, and I'll do a greater than 5. Should I do an or equal to? No, it doesn't say or equal to, it just says greater. Okay. So I'm going to put an open or hollow circle around 5 on the number line. And then n should be everything that's bigger than. So I'm going to put an arrow to the right. Arrow to the right. Okay. I think you guys can probably do the rest here. So I'm going to give you some of the answers to this, just to make sure that you're on the right track. So do B, then C, then D, and the rest, and I'll give you a couple of the answers in a minute once you've had a chance to do that on your own. Okay? So just like that, go ahead and finish the rest of those. Okay, so there's the first 3. If you need to reference those, you guys are going to do the last 3 and on your own. Okay, we're going to be moving to example 7 in just 30 seconds here, so finish those last 3, and we'll take a look at example 7. All right, so let's take a look at example 7. Flip to the last page there. If you didn't get quite finished those ones, you can finish those off a little bit later. Example 7. So here's looking at it a different way. I'm going to give you the solution set or the inequality on a number line, and you have to write the inequality in algebraic symbols. Okay. So this one has at 2 has an open circle. Okay, there's an open circle at 2, so we know what that means. That's not going to include 2, right? So there's going to be no or equal to in this one. And everything is less than 2. You see how the arrow is solid line on the less than. So it looks like whatever this variable is, and we don't know, we can just make up a variable. I'll just say x. X should be less than positive 2. Now I'm not going to do or equal to because it's an open circle, and it's less than because all of the values that are to the left of 2 on the number line are part of the solution set. Everyone okay with that? All right. I'll do the second one for you as well. So this one is going to be a solid dot, so that's going to be or equal to as well, and 5 is the number. It's to the right of 5, so that means it's going to be whatever the variable is, all the solutions are going to be greater than 5, and because it's a solid dot, or equal to. So that's your inequality for B as well. So there's A, here's B. Any questions about that? It should be pretty easy for you. Okay, go ahead and finish C and D, and then I'll give you your assignment for the day.